If you're interested in AI audio engineering, you'll know that there are certain processes that you will apply to all of your projects. The most important of which perhaps is audio preprocessing. You have your dataset and you want to extract features, like for example, a magnitude spectrogram for each of your waveforms and then apply some sort of log scaling or normalization. This is something that I do all the time when I publish a new video here on the Sound of AI channel or when I work on my consulting gigs. But there's a problem. Every time I work on these new projects, I usually rewrite some sort of audio preprocessing script for batch preprocessing all of the samples in my data. And this is quite a hassle because I have to basically rewrite and reinvent the wheel every time. And I'm sure you'll definitely share some of these concerns if you are engaged in this type of projects. Now, to address this kind of problem, I've decided to build a Python library called Praudio. Sorry guys to disturb you, but I just realized while editing the video that I made a major error throughout the video. So I meant to call this library Praudio, but the pronunciation that I have in mind, it's not Praudio, it's actually Praudio. So you'll hear throughout the video me referring to this library as Praudio, but it's actually Praudio because I'm really proud of it. Bye! In this video, I want to show you all about Praudio, how it works, how you can benefit from it, and its design and implementation. So let's get started. In a nutshell, Praudio provides bulk audio preprocessing of full datasets. Let's take an example here. So you have your dataset with 3 different files. Then you can magically apply Praudio, specifying a bunch of different preprocessing steps. So for example, first you want to extract the magnitude spectrogram, then apply log, and finally standardization. And Praudio will take care of that for you. And as a result, you will get your features stored on your hard disk in a directory that you specified. In Praudio, core audio feature extraction is performed by using Librosa as a backend. You can think of Praudio as a sort of wrapper around Librosa that provides you with facilities that allow you to perform multiple audio transforms with a single command. Let's dive into the Praudio codebase for a second, taking a look at the different sub-packages which make up the library. So we'll start with transforms here, and here we have all of those different audio transforms, like for example extracting melt spectrograms or applying some sort of scaling and stuff like that. Then we have a preprocessors. Preprocessors can be used to load a file, apply a chain of transforms, and then store the features extracted on hard drive. Then we have I/O, which is responsible for loading and storing, loading waveforms and storing features. We have creation here, which has a bunch of classes and factories that you can use to create all the different objects available in transforms and preprocessors. And finally, we have config, which takes care of loading, validating, and storing configurations directly from YAML files. We'll see all of this more in detail during the course of this video. Let's take a detailed look at the design and implementation of these subpackages. First thing, we'll take a look at I/O. Here we have loaders to load waveforms and then savers to just save the audio features that we have as NumPy arrays. But the thing that's probably the most important here is this signal class. Now, signal is a data structure, indeed it's a data class where we store a bunch of different information about any signal. So the name, so this could be for example MFCC, melt spectrogram or waveform, then the sample rate, the data where we actually have the values for that signal, and then the file, which is where we loaded this signal from. Now, one thing about the loader, so the loader loads any type of waveforms, or like, for example, it could be a WAV file, it could be an MP3 file, so on and so forth, but then it returns a signal objects, which at the end of the day, you can think of this signal object as the workhorse for the whole Praudio library, because it's passed around all the different objects that we have there. Okay, so now that you have an idea of the IO subpackage, now let's move on to transforms and its design. The most important class we have here is an abstract class called, not surprisingly, transform. This has one main method called process that takes a signal object, it applies whatever transform you have, and then it returns the transformed signal. Now we have a bunch of concrete transforms. So here I'll list all of them. So short time Fourier transform, magnitude spectrogram, power spectrogram, MFCC, melt spectrogram, and log. All of this audio feature extraction are done with Librosa, as I mentioned earlier. Now, we also have scalars. Now, there's a scalar base class which inherits directly from transform. In other words, a scalar is a transform. And then we have a bunch of concrete scalars. Standardizer, which applies z-score normalizations and min-max normalization, called min-max scalar, and a row standardizer. Now, if you want to know the difference, for example, between standardizer and row standardizer, have more information about the implementation, just go check out the code and the documentation. Praudio allows you to chain together different transforms and apply all at once to a single signal. Now, who's responsible for that? Well, that is the responsibility of the transforms chain class. The transforms chain constructor takes the transforms argument, which is a list of transform, and it registers that information in the self.transforms attribute. The main method is once again process. So here we pass a signal, and then this method applies multiple transforms sequentially to a signal, and then it returns that signal with all of the different transforms. And so how does this method do that? Well, we just go through each of the transforms in self.transforms, and then we offload the processing to the respective transform. And we do this sequentially through all the transforms that we have in self.transforms. And finally, we get the fully transformed signal. On top of transforms and transforms chain, we have preprocessors. These are responsible for loading a file into a signal, applying transforms, and then storing the transformed signals or audio features to NPY files. So we have two types of file preprocessors. They are nested together hierarchically, as we'll see in a second. So one is called FilePreprocessor, and the other one is BatchFilePreprocessor. I'm sure you can guess what each of these things does. This is the FilePreprocessor class. In the constructor, we pass three arguments: the loader, then a transforms chain, and a saver. Of course, all of these arguments get registered to instance attributes in the FilePreprocessor instance. Okay, so then we have the main method, which is preprocess. It takes two arguments as input, the file path of the audio file we want to preprocess, and then the path where we want to store the transformed signal. Now, preprocess does three steps. It loads an audio file, then it applies a chain of transformations to the signal, and finally it stores the transformed signal. And as you can see from the code, all of these steps are done by offloading the actual implementation of these processes to the loader for loading, to the transforms chain for applying all of the transforms, and to the saver for saving. BatchFilePreprocessor is responsible for bulk audio preprocessing. Now, you only have one main method there that's called preprocess. You call it, and all of your dataset gets preprocessed. BatchFilePreprocessor contains one file preprocessor object. And of course, just to give you a little bit of a schematic overview of what we already saw in code, file preprocessor has three things. It has a loader, it has a transforms chain which itself has one or more transform objects, and then it has a NumPy saver. To instantiate this complex hierarchy of objects at different levels, Praudio provides a subpackage called creation. At the bottom level, we have transform factory, which is a factory that's responsible for instantiating transform objects. So here we have a create method. We can pass the transform type, which is just a string like stft or log. We can also pass a bunch of keyword arguments, which will be fed to the concrete transforms constructors. Okay, now, on top of transform factory, we have transforms chain creator, which owns a transform factory. Here we have one method called create again, and here we pass configs. In this configuration, we just specify the type of transforms that we want to have in a transforms chain. Of course, this create method will return a transforms chain object with the right transforms instantiated. On top of these objects, we have FilePreprocessor creator, and here again we have a create method with some configs, and the return of this method will be a FilePreprocessor. And on top of that, we have BatchFilePreprocessor creator, which owns a FilePreprocessor creator, and it has itself a create method where we can pass some configs. We'll take a look at the type of configurations that we can pass to BatchFilePreprocessor creator later on in this video. By now, you should have a good understanding of the different elements which make up Praudio. It's time to use it, but before, we need to install it. I published Praudio on PyPi. Here you see version 0.10. Probably while you're watching this, the version may be different. Here you have a lot of information in the README file that you can use. But all of this to say that probably the easiest way to install Praudio, to use it, is via pip. You can easily do a pip install Praudio, launch it, and then this will take care of installation for you quite easily. Now, if you're not just satisfied with using Praudio, but you want to develop it or help contributing development or learn more about it, I highly suggest you to go check out its repo on GitHub. It has its repo at musicarchimist/Praudio, and here you can clone the repo and use it. And while you're here, do remember to star this Praudio repo. With Praudio installed, we can see how to use it. There are two ways. One is on the fly. Basically, you just build the different objects, like for example, a transforms chain, so that you have all the different transforms that you want to apply to your signals, and then use it programmatically. The other one, which is the one that I actually built Praudio for, is more offline. So you have a script, you pass some configurations, and then this script takes care of all of your audio dataset and batch pre-process it. Let's take a look at the configurations first and how we can set them up so that Praudio does what we want. Here's an example of a configuration file. So here we pass all the information that we need to build a batch preprocessor. And as you can see, this is a simple YAML file, and we have to pass a few things. So the first one is a dataset dir. So this is just the path to the audio dataset that you want to pre-process. Then you should pass a save dir, and this is the directory where you want to store the pre-processed dataset. And then you have to pass a file preprocessor, and here you should specify a couple of things. So the loader arguments as well as the transforms chain. So for the loader, you can specify the sample rate and mono. This is a bool, either true or false. And then you should specify the transforms chain, as we said. And here you should list all the transforms that you want to apply sequentially. And as you can see, for each transform, you can pass arguments. For example, for magnitude spectrogram, and passing the frame length, the hop length, wind length, and the type of windowing to apply. For the log, instead, I'm not passing anything. And if I don't want to pass anything, I should just pass an empty dictionary like this. If you're wondering where you can get information about these arguments, just go to the relative code, for example, to the magnitude spectrogram object, and there you'll have all the different arguments detailed in the class. Okay, so now that we have an idea of the type of configuration that we need in order to instantiate a batch file preprocessor, let's take a look at the last sub-package that we haven't checked yet, and that's actually the config package, and I was waiting for this to tell you. Okay, so here we have like 3 different things. So we have a config loader, and the config loader is responsible to load this pre-processing configuration, so loading stuff directly from a config file like this YAML file. And then we have a config saver where we can just save a config file as a config as a YAML file, and then we have some sort of validation just to ensure that we are respecting like basic stuff, syntax in the configuration file. To run offline batch preprocessing, we should use the preprocess entry point. So let's take a look at it. And here we are in the preprocess.py script. To run this script, we should just type preprocess and then pass the path to the config file in the terminal. As simple as that. Now, what are the different steps that preprocess goes through? Well, first of all, we parse the config file, and then once we have it, we pass it to this init batch file preprocessor function that returns the batch file preprocessor with all the right configurations and objects, of course, and then it also returns the configs. Now, we run the preprocess method on batch file preprocessor, and that's it. The magic happens there. And finally, we just save the configuration so that you know what configurations you had when you batch preprocessed your audio dataset. Now that we know what preprocess does, let's run it and see the results. I'll apply the preprocess script to this dummy dataset directory. As you can see here, I have a few files and directories and subdirectories like this. And I also have a config.yaml here. So let's run this and see the results. So we'll do a preprocess config.yaml. It's running perfect. So here we have, as expected, the preprocessed dummy dataset. So first thing in the root, at the root level, we have the configs.yaml so that you always know what types of transforms you've applied when you have like a new preprocessed dataset here. And then here, for example, we have a 0.npy. Now let's take a look at the original dataset, and here you had a 0.wav, and then you also have the same data structure here that's respected with the hierarchical directories. So for example, in test we had a 0.wav. Now let's take a look at the preprocessed dummy dataset. We go in test, and here you have, as expected, a 0.npy. So it's working, and it also reconstructs your dataset recursively for all of your directories. I quite like what Praudio can do, but there are definitely limitations with this package right now, as well as things that I'd like to improve in the future. First type of improvement I have in mind is that of adding more transforms, more possibilities. Like for example, audio augmentation, padding, cropping. Another thing that I'd like to take care of is having the possibility of pre-processing signals with multiple channels. As of now, Praudio works only with mono signals. This may seem a quite big restriction, but in actuality, it's not. Because when we do audio and music processing, most of the time we just down mix our signals so that we deal with mono signals. Then I'd like to turn transform parameters into full-fledged objects. So instead of having a bunch of different parameters, for example, for a short-time Fourier transform, I'd like to create an object which could be called STFT params, for example. In that way, the whole code would look nicer, and that will also help the way we create config objects and stuff like that. Okay, and finally, one thing that I'd really like to implement as well is different types of savers and loaders, but mainly savers. As of now, we can only save like the preprocessed signals as NumPy arrays, as NPY files, right? But it may well be that you want to save them as pickle files or stuff like that. So making a bunch of other concrete savers could be also good improvement for Praudio. And this is Praudio for you guys. I'm really looking forward to using it in my future projects, be them on the Sound of AI channel or for my consulting gigs. But yeah, I think this is going to be beneficial for you guys as well. And I'm really hoping that the Sound of AI community will adopt it, as well as like other people beyond the community. And as of that, please do share this library with your friends, with your colleagues, and with your students. Cool. I'm really also curious to know what kind of features you'd like to see implemented in this library. So just like post your ideas down in the comment section below. That's all for today. I hope you enjoyed this video. And if you're not subscribed to the Sound of AI channel and you'd like to see this kind of content, just subscribe. It doesn't cost anything and it's going to help the Sound of AI channel quite a lot. Cheers for now.